Hi guys, you welcome back to my channel. Today we want to take a look at 2024 Neco past question. They just concluded examination for Neco. We want to take a look at some of the question under organic chemistry, as well as the kind of question in which you are going to come across for those students who are preparing to take JAMB examination next year. This video is for you. So what do you have on the board? Arrange the following isomers in decreasing order of boiling points. We have 2-methyl-butane, pentane, and 2,2-dimethylpropane. We are not here to just tell you that this is the answer. So pay max attention to this. For every boiling point or boiling point increasing order or decreasing order, this is a clue. If, for example, I have alkane, CH for methyl, then I have decane. Is that clear now? One thing about alkane is that for every alkane, when it comes to this decreasing order or increasing order, let's take this short note under it. All alkanes increases with increase in molecular mass, and the same for alkane. For decreasing order, it decreases with decrease with branching. All alkanes increases with increase in molecular mass, and the same for alkane. For decreasing order, it decreases with decrease in branching, either with in or with branching. So take note of this now, class. If looking at this now, class, these are the what? The branches of alkane. We don't know the kind of alkane we have here, but note how many carbon atoms we have here. We have 1, 2, 3, 4, 5. So if there is increase in alkane, vice versa, there also be what? Decrease in alkane. But note one thing: how can we note that this particular compound fall under what? Decreasing? You can easily deduce it based on the branching. If we have butane, pentane, hexane, heptane, octane, nonane, and decane without any substituent attached to it, note that without any substituent attached to it, we can show the what? The decreasing order. So now we are given 2-methyl-butane, and this. Is that clear now? So let's show the what? The decreasing order based on the what? The branching. The first one that will come here will be pentane,
I got it.
and this. We have the next one, because we have what? Just one attachment of what? Methyl, which is 2-methyl-butane, and the last one is 2,2-dimethylpropane. Is that clear now? So guys, this is how we can easily deduce the decreasing or increasing order. So if this go with decreasing order, Then the vice versa will be for what? Increasing order. If, for example, we are having butane here, butane will be the last one as what? Decreasing order. Why? Because if you have to look at the isomer of butane, we are going to have what? 2-methylpropane, which is what? Isopropane. So guys, the next one is we have to name this compound based on the question. Said write the IUPAC name of the following compounds. This is what? The question. If you have to write the IUPAC name of what you have on the board, don't forget that there is always highest priority to the electronegativity element irrespective of the number attached to it. We always give highest priority to the what? The halogen family, that is the alkyl halides, or we call them the alloalkane. Is that clear now? So if we have to name this compound, we start the numbering from here, because bromine have highest priority ahead of what? Methyl. So with that, we can say we have 1, 2, 3, 4, 5. So most students will take this to be what? Pentane. What? Wrong. But if you have to number it as a student that is chemistry inclined, so this is what is going to happen. This one here affects this. Is that clear? We have 2 here, we have 3 here, we have 4 here. So the longest carbon continuous chain here is what class? 4. 1, 2, 3, 4. 4 is what class? Butane. So with one that is here, it affects the bromo here. So we are going to have 1 bromo. The number attached to this methyl will give us 2-methyl butane. As simple as that. So the next one is we're having hydroxy as the attached substituent, as well as we are having methyl as the what? Attached substituent. So how do we name this kind of compound? Mind you, when it comes to organic compound, the rules, if you have to number, you will number where there is highest priority for the attached functional group. The hydroxy here is what? A functional group under the alkanol, which you call the what? The alcohol. So with that, now I can say that I have 1, 2, 3, 4, 5. The longest carbon continuous chain here is 5, which is pent. But because of this hydroxy here, which is a functional group attached to it, we call it what? Pentanol. But now we are going to take a look at where the number at which we have the functional group, which is the hydroxy. We are having 2 here, so you can say 2-pentanol, or we can say pentan-2-or, but then we are having 3 here being attached to this substituent. So this 3 here is what? Methyl. Nothing like 2-pentanol 2-methyl, it is wrong. Or nothing like 2-pentanol 3-methyl, it is what? Wrong. If you have to name it in using the IUPAC nomenclature rules, it is 3-methyl pentan-2-or, or 3-methyl 2-pentanol. Is that clear now? So we can say we have 3-methyl pentan-2-or, or we can say 3-methyl 2-pentanol. Is that clear now? So if we are to what? Take a look at this now. There are some tutors out there who always made a mistake of naming a compound like 3-methyl. This did not obey the IUPAC rules. Is that clear now? So for those of you that are having issues with organic chemistry, check my video catalog for chemistry core, or you can just type anything on YouTube and ask for organic chemistry, other chemistry core. You'll find some useful video that will serve as a guide for you. Is that clear now? So the next one we want to take a look at now is we are asked to state one use of benzene. The first one I'm going to give you, they are used in the production of pesticide. That's the first one. as well as they are also used in the production of what? Drugs. Is that clear now? So the last one I want to make guys to make is they are used as a fuel in motor, which is named as a benzol. Is that clear now? If someone told you that okay, well, benzene is used as a fuel, it is not benzene anymore. It is named what? Benzol. But without benzene, nothing like what? Benzol. So let's pick one of those used. So used in the production of pesticide. Used in the production of drugs. Exactly now. So guys, I will take the remaining question under this. Don't forget I said for this 2024 Neco examination solution, I only want to tell. This one is define saponification. From that word saponification, for those students out there, if you have to look at the production of salt, it comes under these words, saponification. So if you are to understand or to have depth knowledge about this saponification, you need the result we call glycerol, which is 1,2,3 tripropane or propan, 1,2,3 triol. It's the same thing as what? Glycerol. And for simple definition, saponification is the hydrolysis of an esters with a base. So that base can either be sodium hydroxide or potassium hydroxide to yield alcohol or a soap. To yield alcohol or a soap. So with that, I can say esters plus a base, we have alcohol plus soap. So one thing you should take note, that many teachers will not tell you the secret of this saponification. In another way, we can easily say that is the hydrolysis of an esters with a base to yield alcohol or a sodium or potassium of the acid. You can put it that way also if you don't want to use a what? Alcohol and a soap. Let's use and here, and a soap of the acid. Take it like this. And one thing about this saponification you don't know is that for every saponification, they undergo what we call an exothermic process. That is, they gives off heat. Just for example, now when you go home now, like you can take your kitchen or anywhere, take your butter and have your what? Your cooking pot on your cylinder. After some minutes, open your butter and spread it either on your fry pan. You see that thing is going to what? Dissolve. Is that clear now? So for every saponification, they must undergo the hydrolysis of an esters with either sodium hydroxide or potassium hydroxide to yield alcohol and a sodium or potassium of the salt. That word and a sodium or potassium of the salt, we can sum it up to be what? A soap. So don't forget that I said earlier that saponification undergo what we call exothermic process. So let's take the last one. A chloride of an element X has the formula XCl4 and a vapor density of 74. Calculate the relative atomic mass. So if you are to calculate something like this, the first thing you should know is that molecular mass of XCl4 is equal to molecular mass. So one thing you should know is that for this, can say molecular mass of this is equal to 2 multiplied by the vapor density. Exactly, now 2 multiplied by the what? The vapor density. And if you have to solve a question like this, what is our value for this? You can say 2 multiplied by 77, and we have 154. So 154 for the vapor density. Now the value of chlorine is given to be what? 34. So for us to solve question like this, the x here, so it will be 154 equal to this x here. You can say x plus 4, the subscript here. So open a bracket, your chlorine. And class, what is value of chlorine here? The value of chlorine is 35.5. I said 154 equal to x plus 4, open the bracket, 35.5. So then you point your calculator, 4 multiplied by 35.5, so we have 142. So with that, I said 154 is equal to x plus 142. Please don't do the mistake, or majority of you will be like x times 35.5. No, it is what? Wrong. So with that, now we are going to collect our like terms to know the value of x. So when this one comes, we'll be having what? X is equal to 154 minus 142. 154 minus 142. So our x is 12. So class, if we are to replace our x here with this, that is XCl4 is equal to C, because the element with relative atomic mass, please, not atomic number. If it is atomic number, it can be magnesium. So our x, we don't know, can either x is equal to 12, which is a relative atomic mass. We have C, so we can say C carbon Cl4. So you can say to my channel, like, share, and I want to appreciate the effort of all our subscribers for taking us to 900 plus. We are getting there.